Today we are going to start first lesson of 10th Cbse mathematics. It is real numbers. Before going to the lesson, just I want to revise whatever we learned in 9th standard. Here you can see one chart. We have here natural numbers. Natural numbers means it is all the counting numbers 1, 2, 3, dash, dash, dash. Next we have whole numbers. Whole numbers means for natural numbers we have to include 0. That is 0, 1, 2, 3, dash, dash, dash. That is all whole numbers. In integers we have negative numbers as well as all the whole numbers. That is minus 3, minus 2, minus 1, 0, 1, 2, 3. These all the integers. Next we have here rational numbers. Rational numbers means numbers which we can write in the form of p by q, where p and q are integers and q is not equal to 0. That means all the numbers which can be written in the form of fraction. Maybe it is 3 by 7, 5 by 2, minus half, etc. Even all the integers also, because we can write minus 3 we can write by 1, 0 we can write by 1. So all these are rational numbers. Next we have irrational numbers. Irrational numbers, which one we cannot write in the form of p by q and q is not equal to 0. That means the numbers like root of non-perfect squares, root 3, minus root 2, root 7, or numbers like which is 0.101001, which is non-terminating and non-recurring. All these numbers are known as irrational numbers. Now, what is real numbers? Real numbers is the set of all rational numbers and irrational numbers. Now we are going to 10th standard topic. What is prime number and what is composite number? I'll give some example here. 2 is a number. This one we can divide only by 1 and the number itself. So this is a prime number. Next we'll go to 3. 3 we can divide by 1 and we can divide by 3. We can't divide by any other number. So it is having the factors only 1 and 3. This is having the factor only 1 and 2. 5 we can divide by 1 and 5. We can't divide this number by any other number. 7 we can divide only by 1 and 7. Similarly we have here 11 we can divide by 1 and 11. So numbers which can be divisible by only by 1 and itself are known as prime numbers. Next we are going to composite number. I'll give an example. 4 we can divide by 1, we can divide by 4, but we can divide by 2 also. So this number is a composite number. 6 we can divide by 1, we can divide by 6, then we can divide by 2 and 3. So this 6 can be divisible by not only by 1 and itself, it can be divisible by some other numbers also. So these numbers are known as composite numbers. Other example 8, 16, 25, 18, etc. These all are composite numbers. So a composite number is that is divisible by smaller positive numbers other than 1 and itself. We'll see how to find the prime factorization of natural numbers. I'll give an example. Find the prime factorization of 240. So 240 we can divide by 2. It is 120. 2 60 times 2 30s are 2 goes 15 times and 3 5 and 5 goes 1 time. So we are getting here 240 is equal to 4 times we have 2 to the power of 4 into 3 into 5. Now the same number can be factorized in tree diagram. Sometimes it is required in board exam. If we divide by 2, we are getting here 120. Again divide by 2, 60 times 230s are 215. 15 if we divide by 3 we are getting 5, and we are getting here 4 times 2, 3 into 5, 2 to the power of 4 into 3 to the power of 2 to the power of 4 into 3 into 5. Now we are coming to the main topic of this lesson. It is fundamental theorem of arithmetic. I'll make it very clear for you by taking one simple example. I'll take a number 24. 24 is a composite number. I'll write the prime factorization of this. 2 12 times, 2 6 times, 2 3 times. So we can write 2 cube into 3, prime factorization of 24. That same 24 we can divide by 2 12 times. Then we can divide by 3 also. 4s are 2, 2s are, and what you can observe here 3 times 2 was there. Here also we got 3 times 2 we got it. So 2 cube into 3. Same thing we can do like this also. We can divide by 3 8 times. 2 goes 4 times, and 2 2s are, we can write here 2 cube into 3. Maybe we can continue this by taking here 2 12 times, 2 6 are, we can divide by 3 2s are, 2 1s are. So we can write again 2 cube into 3. Okay, maybe still more ways are there. Now here what we can understand, this composite number 24 can be expressed as a product of primes. When we express like this, every time we got 2 cube into 3, and whatever factorization we get, it is unique. It is unique. Here you can see. Okay. Apart from the order how it exists, order can be different. Here we got 3 times 2, then 3 we got. Here we got first 2, then 3, then 2 times 2. Here first 3, 3 times 2, like this. So fundamental theorem of arithmetic says every composite number can be expressed as the product of primes, and this factorization is unique apart from the order in which the prime factors occur. Now we are going to learn how to find the HCF of two numbers or more than two numbers. I'll give an example and I'll explain to you what is HCF. HCF full form is highest common factor. Now I'll give the example here. I'll consider two composite numbers 24 and 36. Now I'll find the factors. See HCF. Now we'll find the factors of this 24. Factors means from which number we can divide this. We can divide by 1, 2, 3, 4, 6, 8, 12. Then by 24 we can divide. Then we find the factors of 36. 36 can be divided by 1, 2, 3, 4. We can divide by 6, 9, 12, 18 and 36. These are the factors of 24 and 36. Now we are finding what is the common factors. Among these common factors are 1, 2, 3 is there, 4, 6 and 12. These are the common factors. Common factors are 1, 2, 3, 4, 6 and 12. Among that, which is the highest one? Highest one is 12. So HCF is 12. That means 12 is the largest number. From that, we can divide 24 as well as 36. Like that we can divide by 2 also, 4 also, both the numbers. But the 2 is the largest number. From that we can divide this, both the numbers. So it is the largest number that divides each of the given numbers without leaving any remainder. Now we are going to learn what is LCM. Otherwise LCM of two or more than two numbers. LCM full form is least common multiple. I'll take one example, simple example, explain to you exactly what is this. I'll consider the numbers 5 and 10. We want to find out what is the LCM of these two numbers. Now, LCM, first we are finding all the multiples. I'll write here 5 and 10. We'll write the multiples 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. It is till infinity. Same thing, multiples of 10 will write 10, 20, 30, 40, 50, 60, 70, 80. This is also till infinity. So m is over. Now we are going for common multiple. Which one are common? We'll see. We can see here 10 is common, 20 is common, 30 is common here. Even we can see 40 and here 50. So common multiples are 10, 20, 30, 40, 50, and this one also, it is still infinite. Now, out of that, which is the lowest one, smallest one, that is the LCM. So LCM is 10. So what is LCM? It is the smallest number, which is the common multiple of the given numbers. These are all the common multiples. Out of that, which is the smallest one, that is the LCM. In other words, the meaning of LCM is, in this case, 10 is the smallest number what we can divide by 5 and 10 both. Same thing here, other numbers are that also we can divide, but 10 is the smallest among that. Now we'll go to the next topic to find the HCF and LCM of the given numbers by factorization method. Otherwise, it is using fundamental theorem of arithmetic. I've taken one example here. Find the HCF and LCM of 12, 72 and 120. Here now 12, we have to find the prime factorization. 2 6 times, 2 3 times. So it is 2 square into 3. Next we are going to 72. 72 when we prime factorize, 2 36 times, 2 18, 2 9 times, 3 3s are. So we are getting here 2 cube into 3 square, and next one is 120, 260 times, 230 times, 2 15s are, 3 5s are. So we are getting here 120 is equal to 2 cube into 3 into 5. Now, what is the HCF of 12, 72, 120 is? We have to find the common factor here, that is 2. Out of that, which one is having the lowest power? That is 2 square. Same thing here, 3 is there in all the 3. So lowest power is 3. Okay, so we are getting 4 3s are 12. That is the HCF of all these 3 numbers. Now to find the LCM of all these 3 numbers, 12, 72 and 120. Here we have to write all the factors which one are presented. This we have 3 and 5. Now you should write all the highest powers of this. Here in 2 highest power is 3, for 3 highest power is 2 and 5 is 1. So we are getting here 8 into 9 into 5. When we multiply, we will get is equal to 360, and that is the LCM of the given numbers. Now we are going to find the relation between HCF and LCM of two positive numbers and their products. I'll take one example. Let the numbers be simple numbers. I'll take, they are 100 and 120. Now we'll find the HCF and LCM of these two numbers. 100, we'll find the prime factorization, 250 times 225 5 times. It is 2 square into 5 square, and 120, 260 times it goes, 230 times, then 215 3 5 times. So 120 is equal to 2 cube into 3 into 5. Now we'll find the HCF of this. HCF of 100, 120 is equal to, we are in the common factor which is the lower power, that is 2 square, and here 5 square and 5 is there, into 5. So we are getting here 4 into 5 is equal to 20. Now we'll find the LCM of these two numbers, 100, 120, that is, we'll write all the factors now. 2 is there, 3 is there, 5. Then we'll write all the highest powers of this, 2 cube, 3 and 5 square. And when we multiply all this, we are getting 600. That is the LCM of this. Now the product of HCF into LCM, that is 20 into 600, we will get 12,000. Then product of the numbers, that is numbers what is given here, 100 into 120, and that is also we are getting 12,000. So here we can understand, for any two positive integers, product of HCF into LCM is equal to product of the numbers. So we can say, for any two positive integers a and b, HCF of a, b into LCM of a, b is equal to a into b, and this one is not true for three numbers.